Hello guys, this is the Med Dude, and today we're doing Edexcel P1 January 2021, and so let's get right to it. So question number 1, a curve has equation y equals 2x cubed minus 5x squared minus 3 over 2x plus 7. Find in the simplest form dy over dx. So the first thing we have to do here is convert everything to an indices form. So this over here we can turn into some minus 3 over 2 times 1 over x. So that's the same thing as saying minus 3 over 2 times minus 3 over 2 times x to the power of minus 1. So that's that. So now we can rewrite this equation. So y equals 2x cubed minus 5x squared minus 3 over 2x to the power of negative 1 plus 7. And then we can just differentiate, so dy over dx. So the 3 will come down, so you will have 3 times 2, which is 6, x to the power of 3 minus 1, so that's squared, minus 5, so 2 comes down, so multiply, so you get 10x, and minus 3 over 2, and then you times by minus 1, so this goes down the power, and this as well, and this as well. So you'll get plus 3 over 2 x to the power of negative 2, because minus 1 take away 1, minus 2. And the 7 we can't differentiate because it's a number, it's a constant, it does not have x, so that's our final answer. Okay, so part B says the point P, so this is the answer. So yeah, this is the answer. So part B is the point P lies on the curve and it has the x coordinate a half. So that's important. So this is the previous answer. Okay. X coordinate half. Find an equation of the normal to the curve at P, writing an answer in ax plus by plus c. Okay, so the first thing we have to do here to get the equation is to get the gradient at P. So gradient at P. Why is that? Because we need to find out the gradient in order to find out the normal gradient, right? So what do you have to do? We have to substitute. So our x equals half into what? Into our dy by dx, into our dy over dx, our gradient function we call this. Gradient function. So we do that, so that will be, so we'll do dy over dx equals 6 half squared minus 10 times a half plus 3 over 2 times a half power minus 2. Okay, so you put it in the calculator, you will get that it is 5 over 2, right? Okay, so we know in order to get normal gradient, we know that it's m times, so let's say the normal gradient. So I'm just gonna write, so this is the perpendicular gradient equals negative 1. We call this the perpendicular gradient. So to get that, we have to do m of the perpendicular is minus 1 divided by m. So this is our m, right? So all you have to do is minus 1 divided by 5 over 2. So that will be, the 2 will go up, so you're left with minus 2 over 5 as our normal gradient. So we can just write normal gradient is minus 2 over 5. Okay, so we've done that. We got the gradient. We know in order to find an equation, we use the y minus y1 equals m bracket x minus x1. But we only have x equals a half. We do not know what the y coordinate is. So what do we have to do? We have to sub into our original y. So that's over here. That's over here. So I'll just change color. So that's this equation over here. So all we have to do is just substitute. So y equals 2 times a half cubed minus 5 a half squared minus 3 over 2 a half to the power of minus 1 plus 7. Right? So put this in the calculator. So you get 2 times a half cubed minus 5 a half squared minus 3 over 2 times a half to the power minus 1 plus 7, and we get 3. We get 3. Okay, so you just put exactly this in the calculator. So now we have our y coordinate as well, which is 3. So we have the coordinate, which is a half and 3. So now we can substitute back into this over here. So that will be, so now we will be left with y minus y1. So y1 is 3 equals m, and now we know our m is minus 2 over 5, and x minus our x coordinate is a half. Okay, so we can put 5 to the other side, so you'll get 5 will multiply this side, and you'll have minus 2 multiplying this side, right? So you'll be left with, so now it's 5y, so it'll be 5y minus 15 equals minus 2x plus, so 2 times, so minus 2 times minus a half, that's plus 1, right? So now we move the 2x and the 1 to the other side, because we want in the equation in the form ax plus by plus c equals 0. So we have to move the x to the other side, so you'll get 2x plus 5y, so minus 15, then take away another 1, so minus 16 equals 0. So that is our final answer. So what are the marks? So you get 1 mark for this. This is our A1 mark. 1 mark for this. You get 1 mark for using this equation over here. So this is a 1 mark. So that's the second mark. And you get a third mark. You get 1 mark for substituting in the beginning. So that's 1 mark as well. So that's our M1. So method 1 mark. M1. And we get the dependent mark over here, so we get another mark here, M1, and we get 1 mark for getting the y coordinate, so over here B1. So these are the five marks that you get. Alright, so moving on to question number 2. So a tree was planted exactly 3 years after it was planted. The height of the tree was 2 meters. Exactly 5 years it was planted, the height of the tree was 2.4 meters. So we've been given an equation that correlates the height and the tree. So this is the equation. So they're asking us to find the significant, to find the 3 sig fig, to find the value of P and Q. Okay, so let's see what we can do here, right? So what we can do is we can do the part A. So we can say after 3 years, what happens after 3 years? We know that after 3 years the height is 2 meters. So we can say what? So 2 cube, we can just substitute into, so t is 3 squared are 9, so 9p, not t, 9p plus q, right? So you get an equation, you get one equation that has 2 unknowns, so that's 8. So you can already know where we're headed. We're headed to our simultaneous equation. So now we have exactly 5 years after it was planned, so we have the 5 years one now. So after 5 years, so what happens after 5 years? So it's the height is 2.4, so we do 2.4 cubed equals, so 5 squared is 25p plus q, right? So you have, so 2.4 cubed, so put that in a calculator, you will get, it is, so 2.4 cubed is 13.824. It equals 25p plus q. Right, so we have our 2 equations and we can just subtract them. So you'll get, so 9 minus 25p, so 9 minus 25 is 16, negative 16p, and 8 minus 13.24 is minus 5.824. So what's p? P is equal to minus 5.824 over 16. So we get what? So that is 0.364, and that is the 3 sig fig. That's fine. So now we need to substitute this value into an equation. So suppose this equation over here, so that will be 8. So that will be 8 equals 9p plus q. So 8 equals 9p plus q. So 8 equals 9p plus q. So what we'll do here will be 9 times 0.364 plus q. So we want to find what q is. So q will be 8 minus 9 times 0 0.364. So you're left with 4.724. But then when you obviously have to round it because the 3 sig fig, that'll be 4.72. So this is our answer. So Q and P. So that's our value P and Q. So you get 1 mark for 4.72, 1 mark for, so you get 1 mark for stating this, one mark for this, 1 mark for this, 1 mark for getting to this calculation, the simultaneous one, and 1 mark for getting this equation right. Those 4 marks. Okay, so exactly t years after the tree was planted, its height was 5 meters. So part B, find t. So we know the initial equation was what? It was h cubed equals p t squared, because we're using capital T now, plus q, right? So we know the height was 5, so we can just cube it. So 5 cubed equals, we know what p is. P is 0.64, so 0.364 t squared, right? We know what q is, plus 4.72, right? So all we have to do is find what t squared is, right? So that will be 5 cubed, take away 4.72, right, equals 0.364 t squared, and then we can just do t squared equals, so 5 cubed minus 4.72 divided by 0.364, and to put in a calculator, all we have to do is square root it. Square root 5 cubed, take away 4.72, all over 0.364. So we can do plus or minus, but we know the time is positive, so we don't have to put the plus or minus. So this equals, so put this in the calculator, so it gets square root of 5 cubed minus 4.72 over 0.364. So you get 18, so 18.178, and it goes on. So we can just round it off. So we can round it to, they want it to 1 decimal place. You see over here, 1 decimal place. So that will be 18.2. So that is our answer. All right. So question number 3. Question number 3. So figure 1 shows a sketch of a part of the curve with the equation y equals 4 cos x. The point P and Q lie on C1. They lie on C1 and are shown in the figure below. So this is a 4 cos x graph, right? So that means that our intercepts now multiplied by 4, right? So it's stretched by 4 vertically. So this is 4. So this, if this is 4, this means that this is negative 4, right? Okay, so we know that one cycle takes 360, right? One cycle is 360, so that's 360 degrees. So if that's 360 degrees, we know that this over here is 180, and if that's 180, then this is 90, and then this is over here, this is 360 plus 90, so that's 450. So we know that. So if we go back now, so that will be negative 90. So this over here will be negative 180, right? Degrees, obviously. So we know the 2 points on the x-axis. Now we need to find out the y-axis, right? So the point P we've just seen is, so the x-coordinate is minus 180 degrees, and the y is the minimum point, so that's going to be minus 4. What about Q? Q is already on 0. You can see it's on the x-axis, so it's its y is 0, and its x we have calculated, it's 450 degrees. 450 degrees. So those are your 2 answers. Okay, easy as. So y, the curve C2 has equation 4 cos x plus k, and curve C2 has a y value of minus 1, right? The point R is the maximum point in C2 with smallest positive x coordinate, stays the coordinate of R. So we have C1, right? C1 was y equals 4 cos x, right? And we know its minimum point was minus 4 and its maximum point was 4. So this was the min and max, right? Now they're saying the minimum value is -1. So that means what do we have to add? So what do we have to add to this to get -1? So what do we have to add? So -4 plus k equals -1. So that will be, so k will be 4 minus 1, so that will be just 3. So we know what k is, right? So we know the y, it's 4 cos x plus k, right? We know that. So where k is now 3, right? So we know what C2 is. This is C2. But what about now? They want the maximum point. So if you go back up here, the maximum point is at 0 and 360, right? You get 4. But obviously if we have plus 3, that means our maximum point will now, so if I change the color, so our maximum color should be over here, 7, and it should be translated up, so that will be 7 as well, right? So they want the smallest positive x coordinate. Now 0 is not positive, it's not negative either. So the smallest positive will be this point over here. So that will be what? That will be 360, and our y coordinate will be 7. So we can write, so r, the coordinate of r is 360 degrees, and y coordinate is 7, right? So that is part B done. That is the answer. We can move on to question 4. So point P and Q are shown in the figure below. Respectively, find an equation for L. For L, writing an answer in y equals mx plus c, where m and c are to be found. So we have two coordinates over here. Okay, we have two coordinates over here, and all we have to do is use straight line geometry, right? So all we have to know is find the gradient between the two lines, right? So we have to do what? So m is the change in y over the change in x, right? So if we take this as x1, y1, x2, y2, so we'll just do y2 minus y1. So y2 minus y1 over x2 minus x1. So that will be -5 minus 13 over 4 minus -2. That'll be minus 18 over 6. So that'll be -3. Right? So we know what the gradient is. So we know that. Okay. So now what do we do? So we know the gradient. What do we do now? Now we do y minus y1 equals m x minus x1, and we just use one of the two equations. So let's use this one. So that will be y minus 13 equals m. What's m? M is -3, x minus -2, so that's +2. So you're left with y minus 13 equals -3x plus 6, right? So yeah, sorry, not +6, -6. Sorry, go back. It's -6. So y equals -3x plus 7. So that is our equation. So that's our equation. Y equals -3x plus 7. Alright, so that's our equation. So the quadratic curve C, so they're talking about this curve. They're talking about this, wait, no, this is too similar. So they're talking about this curve over here. They're talking about this curve, the quadratic curve. So they're saying the quadratic curve passes through P and has a minimum point at Q, right? So passes through P, it has a minimum point of Q. Okay, so if we know the minimum point, we can think of what? We can think of completing the square form. Completing the square. So because of that, what we can do, right? Because we know the minimum point, we can say that it's x. So what's P? P is, this is P. You know, P is 2 minus 2 and 13. We can do x plus 2 squared minus the y was -13. So this is correct so far, but we don't know the stretch of, we don't know if it's stretched or if it's like this, right? We don't know that yet. Right? We don't know that yet from this equation alone. But we do know this will give us the same minimum point as -2 and 13, right? So what now? We don't know the A, so what we have to use is, so part B is still going on here. So this is still part of part B. So we use our P coordinate minus 2 and 13, minus 2 and 13, and we just substitute. So our y should be a, so x plus 2 squared minus 13. So we just substitute our y, x, and y. So that will be what? So minus, sorry, not minus, 13, sorry, not, was that p? Oh, sorry, not p. I have to use not t. That was supposed to be used to use q for this, sorry, because q is the minimum point over here. Q is the minimum point over here. So q is the minimum point, so that is 4 and minus 5. So evidently that should also be, so that should also be minus 4, right? And minus 5, yeah. Minus 4, minus 5, sorry, my bad. So over here as well, so that should be minus 4, that looks like minus 4 squared minus 5. And yeah, then we just substitute our p from the equation over here to confirm. So that will be 13a minus 2 minus 4 squared minus 5. Okay, so if I go the other side, you get 18 equals a times minus 6 squared. So that is 18 equals 36a. So what is a equal? A equals 18 over 36. That equals a equals a half, right? So our final answer is y equals a half x minus 4 squared minus 5. So that is the answer for here. So that is the answer. So we can say so let me tell you the marks that we get for this. So you get 1 mark for getting the answer. You get 1 mark for this. We get 1 mark. We get 1 mark for getting to this stage. That's 1 mark for this. Like getting to x squared minus 4x minus 4 squared minus 5, and 1 mark at the end to get a. All right. So the region R shown in the figure, so shown here in that figure, lies in the second quadrant and is bounded by C and L only. Use inequalities to define the region. Okay, so we want this region over here. So what we can do is, let me erase this. So yeah, so what we can do is we can shade what part we don't want, right? So we want what do we want? We want everything that's below the line, right? So we want everything that's below this line, right? You can see here. We want everything that's above this line, right? So because we want it above this line, we can say, we can write, so we want y is above the line, so that's minus 3x plus 7. That's this line. So that's one of our equations that we need to write. Okay, what else? We also know that we also want everything outside the quadratic graph, right? So you can see over here that it's everything that's outside the graph. So that's below the graph, right? That's below the graph. So we can just do this. So we can, let me change this to this. So we can just say over here, we want everything that's below the graph, right? So everything that's below the graph. So what's that? So that's going to be everything that's below the graph. So that's going to be half x minus 4 squared plus 5 minus 5. And what else? We also know that over here you can see this is one of the lines. So this line is what? We know this line is what? X equals minus 2, right? It's like x equals minus 2. And all of the region, it's the region, let me go over here. The region, let me use a different color. So the region, we want everything that's before minus 2, right? So we want everything that's before. So that means we have our another equation, our last equation, which is it has to be less than -2. So these are our three equations that we need for our region R. Alright, so question number 5. Figure 3 shows a plan viewing platform at a tourist site. The shape of the viewing triangle consists of sector, this is the sector, and they tell you information. So OA is 6, so OA is 6 centimeters, and AD is 14 centimeters. We know this is also 6 centimeters because it's the radius. So angle ADC is 0.43 rad, 0.43, and angle OAD is an obtuse angle, so it's larger than 90 degrees. Okay, so it's above 90 degrees. The angle is above 90 degrees. Alright, so, and OCD is a straight line. So we know the straight line. So now what? So they're asking, so what's the first question? The first question is find the angle AOD. So find this angle over here. I'm going to call this X, right? So instantly you should think about what we can do here. And the only thing we can do here that's viable is using the sine rule, right? So why do we do sine rule? Because we have an angle. So we have one angle and we have two sides, and we know the angle over here as well. So the only option we should use is use the sine rule. Sine x over 14. So you know the opposite side's here, and opposite of 0.43 is 6. So that'll be sine of 0.43. Don't forget to put it in radians, your calculators, so over 6. So sine x is equal to 14 multiplied by sine 0.43 all over 6, and you can just inverse that, and you'll get, so 14 sine 0.43 over 6. So what do we get? We get 1.337 radians, right? But is this the final answer? Because they tell us that angle AOD is greater than 90 degrees, and 90 degrees in terms of pi is pi over 2, right? Now pi over 2 it's not greater, so if you do pi over 2, you'll see if you do pi over 2, it's 1.57, right? So this is approximately 1.57, right? So this angle is less than that, so we have to take the obtuse angle. So that will be, so angle AOD will be pi minus 1.337. So our actual answer is 1.805 radians. So I'll just put 1.805 rad. And they wanted 3 decimal places, so our final answer is this. This is our final answer. So we got 1 mark for using the sine rule, we got 1 mark for getting over here, and 1 mark at the end for the answer. Alright. So the length of arc ABC in meters into 1 decimal place. Okay, so we know the arc ABC. So the arc ABC is what? So it's this arc over here. If I can get it over here, so it's this arc over here, this one over here. So the way we get it is we get this angle, right? Let's call this angle Y. I'll just call this angle theta then. Yeah, and the way we find arc length in terms of radians is just r theta, right? So our arc length for this will be, so r is what, 6, and what's our theta? We know what x is, right? It's 1.805, and you know a whole circle is 2 pi, right? So it's going to be 2 pi take away 1.805. So 6 times 2 pi minus 1.805, and that is 26.869. So what did they want? They want to 1 decimal place. That's the key thing here. So we can round it to. So this is part B. This is part A. So this is 26.9 centimeters. Sorry, not centimeters, sorry, meters. Sorry. Meters, and this should also be in meters. So that is 6 meters and meters, and this as well should also be in meters. So this should be in meters. All right. So yeah. So this is the answer for this. 26.9 meters. Okay. So total area of the viewing platform in meters squared to one decimal place, right? So how do we get that? So we need the area. We need the area of the sector, right? We need the area of this sector, right? We need the area of this sector. If I just call it, we need the area of this sector plus the triangle, right? Plus the triangle. So how do we get that? So we know, so we can just write, so part C over here, we can say total area is area of sector plus area of triangle, right? We just put a triangle there. So what's the formula for area of a sector? It's half r squared theta, right? And area of a triangle is half AB sine C, right? Okay, so we know that. Okay, so let's look at theta. We know what theta is, 2 pi minus 1.85. So this is our theta. We know this already. So this part's easy. So all we can go straight away. You can just say half. You know, r is 6, so 6 squared times 2 pi minus 1.805 plus, what about our triangle? So we have our triangle, right? We know this length is 6. We know this length is 6, right? We know this length is 6. But we don't know this full length. We don't know this length, right? We don't know this. So we have to use these two sides, right? These two sides over here, 6 and 14. But we don't know this angle over here. So we have to find that angle out, right? So we know what x is. X is 1.805. So we have to do, so to find this angle, we're just going to call this y. So we have to find y first. So that will be what? That will be y plus 0.43 plus 1.805 equals pi over 2, right? Sorry, pi. So 180 degrees, right? So y equals pi minus 1.805 minus 0.43. So that is, so pi minus 1.805 minus 0.43, that is 0.91. So 0.91. So now we have to just put it in the calculator. So half times 6 times 14 times sine 0.91. So once you do that, what do we get? So you can just put it all in calculator. Put it all in the calculator. So we will get at the end. So we will get. So this is 80.6 meters squared plus this. The triangle over here is 33.1 meters squared. So you're left with 113.7 meters squared. So this is our final answer. All right. So what do you get the marks for? You got 1 mark for this, stating this, that it's a combination of sector and the triangle. 1 mark for showing the working out. 1 mark for getting this area, and 1 mark for getting this area. And obviously at the end to get A1, the accuracy mark, which is 113.7 meters squared. All right. So question number 6. So it's a sketch the curve with equation minus k over x, right? So that's what we have to do. We have to sketch. So we can just do it here. So I can get over here. So all right. So we have this. So sketching minus k over x is easy. It's just like this is the reciprocal graph. Same thing over here. It's the reciprocal graph. So this will get you to 2 marks. So we get 1 mark for the reciprocal graph, and we get 1 mark for it because it's negative, right? All right. So that's the 2 marks. What about another reciprocal diagram? Sketch minus k over x plus k. So this is actually pretty simple. So I'm just going to copy this, and I'll do it over here. I'll do it over here. B. Paste. So we're gonna increase it so it's easier to see. Okay. So this is x. All right. So this because we have plus k, we're going to have what? We're going to have an asymptote, right? We're going to have an asymptote. So that means we're going to have what? That means that this is going to be shifted upwards, right? So this will be shifted upwards. This will be shifted upwards a bit, and this will also be shifted up a bit. This will be shifted up a bit. So we'll have a line going through, which will be k. So this will be our asymptote. So this will be y equals k. It's still the same graph. It's still the same graph going this way, and this is still the same graph going this way, right? But now we just have y equals k, and we have an intercept, right? Because what do we know about the coordinate of the intersection of the x-axis, right? What do you know about that? So it's easy. What you have to do is just equate it to 0. So this will be 0. So our y is 0. So this is 0, right? So it'll be k over x equals k. So kx equals k. So x equals k over k. So equals 1. So this over here, this coordinate over here is 1, 0. Right? So this is 3 marks. So 1 mark for the asymptote, 1 mark for the asymptote, 1 mark for the coordinate, and 1 mark for the correct shape. Alright. Part C. Find the range of possible values of k for which the curve does not touch or intersect with this line. Whenever you see the question does not touch or intersect, when they talk of intersection in terms of graphs, we always need to think of whether I'm going to get at the end a discriminant or not. So let's see what we get here. So part C. So we have 3x plus 4 equals minus k over x plus k. So we can multiply everything by x. So that will be 3x squared plus 4x equals minus k plus kx. So we move everything to one side. So 3x squared plus, so this is 4 minus k. So 4 minus kx, the k goes this side. We can take it as a factor. Plus k equals 0. So now we need to do what? We need to take the discriminant, right? So b squared minus 4ac. We need to take discriminant. So what's b? We know b is 4 minus k, right? B is 4 minus k. Our a is 3. And our c is k. So let's do that. That will be 4 minus k squared minus 4 times 3 times k. We have to equal it to 0 first to find the critical values. So let's expand the bracket. So that will be 4 minus k times 4 minus k. So minus 12k equals 0. So let's expand. So that will be 16 minus 4k minus 4k. So that minus 8k plus k squared minus 12k equals 0. So that will be k squared minus 20k plus 16 equals 0. So now what? So now what we can do is we can solve. We can use the quadratic equation. So that will be what? So that will be k equals, so minus b, so it will be plus 20. So minus 20 plus or minus, so b squared is minus 20 squared minus 4 times 1 times c all over 2a, so 2 times 1 because we have, k is 1. So when you simplify this k, so let's put it in the calculator. So what do we get? So we get minus 20 plus or minus, so square root minus 20 squared minus 4 times 1 times 16. Okay, so we get 10 plus or minus 2 root 21. That's what we get. All right, so these are the what? Critical values. All right, so what happens when we know that it does not intersect? What can we say about the discriminant? It's less than 0, right? b squared minus 4ac less than 0. So that means k is here, and this is 10 plus 2 root 21 and 10 minus 2 root 21. So this is our answer. This is the range. So we got 1 mark for getting the equation. So you got 1 mark for getting this equation over here, 1 mark for getting the critical values, 1 mark for getting the answer, and doing b squared minus 4ac. Alright, so that's the answer. So let's move on to question number 7. So question number 7, we have f of x, 2x minus 3 root x minus 5. So we have to solve the equation f of x equals 9. So let's do that. So that will be 5 f of x equals 9. So that will be 2x minus 3 root x minus 3 root x minus 5 equals 9. Alright, so some people may be confused. So what do we do here? This is not a quadratic equation. How do we solve this? Now you can just imagine it as if it was a quadratic equation. So you can just do y equals root x, because root x is what? Root x is x to the power half, right? And what's root x to the power half squared? That's x, isn't it? So essentially this is still a quadratic equation, right? Just another form of it. It's just another form of polynomial. So what we can do is we can just use y instead of root x if we don't understand what's going on here. So this will be 2y squared minus 3y minus 5 equals 9. So this is simpler. 2y squared minus 3y minus 14 equals 0. Now what? We can factorize this, right? This is factorizable. So this will be 2y minus 7 bracket y plus 2. You can also still use the calculator to solve it directly. So this is what we have here. So 2y minus 7 equal and y plus 2. So our two answers could be 2y minus 7 equals 0 or y plus 2 equals 0. So let's do y plus 2 equals 0. So now we can just put our root x back there. So root x equals minus 2. So we can't have root of a number that gives us a negative number, right? A root of a number all gives us a positive number, right? We can't square it. Yeah, so root x equals minus 2. So in this case, what happens then? What happens then? So because we want x is greater than 0, is it? You see this? X is greater than 0, because if we square root it, that's minus 4. Okay? So square root of 4 is plus or minus 2, right? So we still can't get x because we can't get minus 2 here, so that's why we disregard it as a whole. So we're left with our other equation. So that's 2 root x minus 7 equals 0. So we have 2 root x equals 7. So root x equals 7 over 2. Now we gotta square it. So we'll get what? So we get x equals 7 over 2 squared. That'll be 49 over 4. So that's our answer. Our only answer is 49 over 4. Right? So that is the answer. So I'm just going to do that. And minus 2 is not the answer. So or minus 4 is not the answer. Alright, so that's the answer. We got 1 mark for 1 mark for getting 49. We got 2 marks for getting to 49 over 4 over here. 2 marks for getting over here, and we got 1 mark for getting over here using quadratic equation or formulating an equation, and we got 1 mark for saying that this is not viable. It's not a solution. All right. So now solve the equation f. This is differentiating twice of x equals 6. We can do that. So part B. So we know f of x. So we know what's f of x. We know f of x is 2x minus 3x to the power half, right? You can change that, minus 5. And this, so now we have to differentiate it once. So 5 root x. So that we differentiate once. So what do you get? We get 2 minus, so half goes down. So 3 over 2 x to the power minus half. And that's it. Okay, so what if we differentiate it twice? And what happens? So this went down, right? So this goes down again, and we take 1 away from the power. So this becomes, so minus 3 over 2 times the half. So it will be 3 times 1 over 2, so 3 over 2 times 1 over 2, and x is minus 1 minus half minus 1, so that's minus 3 over 2. You can simplify this, so this is 3 over 4 x to the power of minus 3 over 2. This equals 6. Okay, so now all we have to do is rearrange. So that will be, so 3x to the power of minus 3 over 2 is 24. So x to the power of minus 3 over 2 is 24 divided by 3. That is 8. So now you can just use the calculator, or you can change it to better fit what you have to do. So I'm just going to do this. So x to power, we could take down. So 1 over x to the power of 3 over 2 equals 8. So now we can put this here, and 8 can go down. So that will be 1 over 8 equals x to the power of 3 over 2. So what does that actually mean? That means it's 1 over 8 is equal to, right? It's equal to root x. So that's the over 2, right? That's the denominator. That's cubed, right? So now we have to cube root 1 over 8. So we can do that, root x. So we cube root 1 over 8. So that gives us, so root x gives us 1 over 2. So our x is 1 over 2 squared. So that is 1 over 2 times 1 over 2. So that's 1 over 4. So our final answer is 1 over 4. So that's our final answer. Alright, you can avoid the ending if you just use a calculator. You can still get the same marks. That just to show that you can still use do it without a calculator as well and still get full marks. This is better, it's more safer. Okay, so question number 8. Okay, so figure 4 shows a sketch of part of a curve C with the equation y equals f of x, where f of x is 3x minus 2 whole squared multiplied by x minus 4. Okay, so deduce the values for which f of x is greater than 0. So this is our y equals 0. This is 0, right? F of x equals 0. So what point is that that's greater than 0? So that's when this is equal to 0, right? So what are those values? So that's going to be either 3x minus 2 equals 0 or x minus 4 equals 0. So we can get it's x equals 2 over 3 or it's x equals 4. So which one is this? This is obviously x equals 4, right? And this is our x equals 2 over 3. So we know the values for which it's greater than 0, it's going to be the values greater than 4, right? So that's our 1 mark over here. Alright, so part B, expand the form f of x. So expand the form f of x to the form ax cubed plus bx squared plus cx plus d. Alright, so this is actually pretty simple. All we have to do is expand, and we're gifted 3 marks for this. So all we have to do is expand. So this is 3. So I will just, okay, that's 3x minus 2. So squared, so we'll multiply it again, 3x minus 2 times x minus 4. So this is just multiplying this. So first let's do that. So that will be 3x times 3x, so that's 9x squared. So 3 times minus 2x, so that's minus 6x. Minus 2 times 3x, that's minus 6x again. Minus 2 times minus 2 is plus 4. So that's what we have so far. Alright, so let's see if we can simplify this. So when we simplify this, this becomes what? You're left with 9x squared minus 12x, because we can collect like terms, minus 6x plus 4 multiplied by x minus 4. Alright, so now what? So now we can do it 9x squared times this. Then we can change it. So we can change it so we can get, so it's over here. And then the last one over here. Alright, so what do we get? We get, so 9x cubed, let me change the size. So we get 9x cubed minus 9 times minus 4 is minus 36 x squared minus 12x times x is minus 12x squared, And then minus 12x plus 4x, that's plus 48x. And then 4 times x is just 4x. And minus 4 times 4 is minus 16. So we can just collect like terms now. So I'll tell you the like terms. So these are the like terms. These are the like terms. So we can collect them. So we're left with, so f of x is, so 9. So 9x cubed. So minus 36 minus 12, that's minus 48 x squared. So 48x plus 4, that's 52x minus 16. So that is our final answer. Alright, so easy 2 marks. Alright, so we have the line L, so shown in the graph. So this line L passes through the y-intercept of C. So the y-intercept of C, so this is the y-intercept. We know the y-intercept is this over here, right? It's minus 16 because it's the non-x term, right? So we know that. It's parallel to the x-axis. Okay, so we know that. The line cuts C again in points P and Q. Okay. Using algebra and showing you working, find the length of line PQ. Write your answer in the form k root 3, where k is a constant to be found. Alright, so what are we actually looking for here? We're looking for when f of x, right, equals, so f of x, so this is the line, so f of x equals line L, right? So we know what f of x is, it's over here, so I'm just going to write f of x for now. What about the intercept? We know the intercept is minus 16 over here, right? So we have to just do f of x equals minus 16, okay? And we need to get the 3 intersections. So we know that we will get one intersection that x equals 0 already. We can see that. But we'll get 2 others. And all we have to do, and because they're on the same line, all we have to do is subtract the x coordinate of both to get the distance, right? Because the y coordinate is the same, right? They're not changing. So that's all we have to do. So that's the steps, right? So these are the key things we have to do, right? So we have to, this is what we have to do. So we have to equate it, then find the x coordinate, and that's it. Okay, so let's do that. Let's do that here then. So let's do that here. So let's do that. So f of x we know from previous is f of x is 9x cubed minus 48x squared plus 52x minus 16. So this is equal to minus 16, right? So the 16 can cancel out. We move the other side. So you'll be left with 9x cubed minus 48x squared plus 52x equals 0. So how can we simplify this? We can take x as a common factor. So x will become 9x squared minus 48x plus 52, right? Equals 0. So now what do we do? So we know that either x equals 0 and 9x squared minus 48x plus 52 equals 0. We know that, right? We know that. And we're not concerned with x equals 0, so we can just leave it. So now what can we do here? We can use the quadratic formula for this, right? So we can write x equals, so minus 48 plus or minus square root b squared, so minus 48 squared minus 4 times 9 times c, which is 52, all over 2a, so 2 times 9. So what's our x? So we can use a calculator here. Square root of minus 48 plus square root, so minus 48 squared minus 4 times 9 times 52 all over 2 times 9. So you're left with, so you get 8 plus or minus 2 root 3 over 3. So that's what you get. That's what you get. Okay, so we know that P is smaller than Q, so we know that P is going to be 8 minus 2 root 3 over 3, and our y is obviously minus 16, and our Q is going to be 8 plus 2 root 3 over 3, and that's also minus 16. So how do we find the distance? So to find the distance, so if I can move on from here, so find the distance, all we have to do, so distance, all we have to do is what? Remember, is px, the x component of p and the x component of q, we just subtract them. So you get, so we have to do, sorry, the q, because it's the same thing, we'll get a negative number. So q x take away px, the larger take away the smaller, that will be 8 plus 2 root 3 over 3, take away 8 minus 2 root 3 over 3. So we get, this will be 8 minus 2 root 3. You want to calculate as well, so plus 8, sorry, not plus 8, minus 8. Minus 8 plus 2 root 3 over 3. So you can see over here that the 8 will cancel out. So you're left with, what are you left with? You're left with minus 2 plus, no, plus or minus this 8 plus minus 2 root 3, so q minus p minus, oh yeah, it's plus, I made a mistake here, sorry. It should be plus over here, my bad. Sorry, plus, sorry, plus. And so you're left with 4 root 3 over 3. So that's our distance. So this is our distance of PQ. And they want k root 3, where k is the constant to be found. So k is 4 over 3. So this is our final answer, 4 root 3. K is 4 over 3. Alright, so that's that. So our marks we get is, we get 1 mark for showing that we equated to 0 after putting in minus 16. We get 2 marks. We get 2 marks for getting to this stage, for solving to find our 2 equations, right? And we get 2 marks for stating that it's 4 root 3 over 3, and 1 mark for stating k is 4 over 3. So these are the other 2 marks. Alright, so let's move on to question number 9. Question number 9. Alright, this is the last question. So find the integration of 3x plus 2 whole squared over 4 root x, giving you a form in the simplest form. Alright, so in all these equations, all of these expressions, we always try to simplify first. So let's do that. So that's going to be, so let's just simplify instead. So that will be 3x plus 2, 3x plus 2, and it will be, so this will be 4x to the power half, right? So let's now simplify this. So this will be 9x squared plus 6x plus 6x. So that's what we're doing. We're multiplying the brackets, right? Plus 4 all over 4x to the power half. So you're left with, so let's simplify this again. So 9x squared plus 12x plus 4, and all divided by 4x to the power half. So this looks like a 9, 4x to the power half. Alright, so let's see, can we simplify it further? Let's see. So yeah, so this will be just 9 over 4. We can 9 over 4, so we can now take each term. So we can take these terms separately and divide them by 4x to the power half. So 2 minus a half is 3 over 2. X minus, so 1 minus a half is just, so 12 over 4 is 3. So x to the power half. And what about this? The 4 divided by 4 is 1. So this is going to be 1. So that's going to be x. And this is no power. So this will just be x to the power of minus a half. So now we can integrate this. This is easier to integrate, right? Much easier. So let's do that. So we have to integrate now. We have to integrate 9 over 4, x to the power of 3 over 2, plus 3x to the power half, plus x to the power of minus 1 over 2, and don't forget the dx, right? So what's that equal to? So we know that whenever we have this sort of integration, we have to add 1 to the power and divide by the power. So that's going to be 9 over 4, x to the power of, x power, so add 1, 3 over 2, you get 5 over 2, right? And if we're dividing by 5 over 2, we're also timesing by 2 over 5, right? Okay, so plus what? So x to the power of a half plus 1, that's 3 over 2. So 3 times x power 3 over 2. And if we're dividing by 3 over 2, that's the same thing as timesing by 2 over 3. That's fine. Plus, so minus a half plus a half. Sorry, minus half plus 1, so that's a half. So x power of half. And if we're dividing by a half, that's the same thing as timesing by 2 plus c. So final answer should be, so if we just write it neatly, so the final answer should be 3x plus 2 squared over 4 root x dx is, so we have to multiply this and this together. So this will be 9 over 4 times 2 over 5. That'll be 9 over 10 x to the power of 5 over 2 plus, so 3 times 2 over 3, that's 2 x to the power of 3 over 2, that's plus 2x to the power of half plus c. So that is our final answer. Alright, so what are the marks for this? You get 1 mark. We get 1 mark for getting to this, right? Splitting them into terms. You get 1 mark for that. We get 1 mark. We get 2 marks at the end to integrate it properly. 2 more marks at the end to get this and plus c. 2 here and 2 here. Alright, so the last part, okay, so let's see, this is curve C has equation y equals f of x. So the differential, so the differentiation of f of x, you get x squared plus ax plus b. So y-intercept is 8, so we know that our c at the end will be minus 8. What else do they tell us? They tell you that point P, this point lies on C. The gradient is 2 at P. This is very important. So because we need to understand, if we understand this, we can understand the whole question. The whole part of the question is saying we can actually do this. So the gradient is also the differentiation, right? Gradient function is also the differentiation, right? So the differential of f is what? So at 2 is what? So not at 2, at P. That's over here. So that's 3, right? So the gradient function at 3 is 2, right? It's 2. So that means what else can we do? What can we do? What can we do? We can do a couple of things, right? What can we do? We can substitute, right? So f prime of 3, right, is what? So we know this 3 squared plus 3x plus b equals 2. Not x, a, sorry. This should be a. Plus 3a plus b, right? So now what? We can simplify this. So this will be 3a plus b. That's 3 squared is 9. This is 2. This will be 2 take away 9 over in this end. So this will be negative 7. Right, we got there. What else? We can integrate this, right? We can also integrate this, right? So to get to where we want, right? So let's do that. So let's integrate that. So if we integrate f, differential dx, we should get f of x, right? So that's the same thing as saying, so integrate it. So we get what? We have to integrate x squared plus ax plus b dx. That's equivalent of saying, so that's what? So that's going to be x cubed over 3. That's going to be ax squared over 2 plus bx plus c. So that's f of x, right? That is f of x, right? That is f of x. And what did we say in the beginning? We know that c is minus 8, right? So what now? We know that f of x is that, so we can formulate another equation, right? We know that at P, y is minus 2 equals what? We can substitute 3 squared, 3 cubed over 3 plus a times, so 3 squared over 2 plus We don't know what b is, so bx. We know what c is, minus 8, right? So this is one equation. Let's simplify this. So how do we simplify this? So this will be, this equation will be minus 2. So 3 cubed is 27 divided by 3 is 9. 9 plus 9a over 2, right? 9 over 2, or no, 9 over 2, sorry. Yeah, 9 over 2, not 4. Plus bx minus 8, right? What else? What else do we know? Because, so let's simplify it. So now what? So let's, not bx, 3b, sorry. This should be 3b, because x is 3, isn't it? Let's simplify. So this will be so this will be 3b. 3b minus 8. 3b minus 8. So we can still simplify this, so we can go forward. So this will be minus 2 equals 9 plus, so not 9 minus 8 is 1, plus 9a over 2 plus 3b. Okay, so 1 goes the other side, get minus 3 equals 9a over 2 plus 3b. I still don't like the fraction, so we can multiply everything by 2. So you get minus 6 equals 9a plus 6b. This is our second equation. So we have our two equations. We have 9a plus 6b equals negative 6. We have 3a plus b equals negative 7. So we can multiply this by second equation, or the bottom equation, by 3. And we get what? So let's try that again. So this will be 9a plus 6b. The top is still the same. We're multiplying everything by 3 now. That'll be 9a plus 3b equals minus 21. We subtract. So 6 minus 3 is 3b. 6 plus 21, minus 6 plus 21 is 15. So 3b equals 15. So b equals 15 over 3. So b equals 5. Right? So we know b equals 5. What about a? We can just substitute back into the equation. So 3a plus 5 equals negative 7. So 3a equals negative 12. So a equals negative 12 over 3, which is negative 4. So a equals negative 4. Now because we have done this, we can do what now? Because we want to find the simplest form, right? So we can just substitute a and b and c back into this equation that we have initially of f of x, right? So our final answer, f of x equals, so x cubed over 3. So x cubed over 3, so that stays as it is, right? So x cubed over 3 stays as it is. What else? X stays as it is. Then what? Ax squared. So we know what a is, minus 4, right? Minus 4 over 2 is minus 2x squared. What is b? B is 5, so plus 5x, and c is minus 8. So this is our equation at the end, right? So this is our final equation at the end, right? So this is our final answer. Final answer. Alright, so where do we get the marks? So we get 1 mark obviously at the end for this. We get 1 mark for this. Let me just 1 mark for this. What else do we get the marks for? We get 1 mark for, so let me just go back. So 1 mark for 2 marks for this, the 2 marks for this, getting a and b. What else? 1 mark for getting to this. 1 mark to getting to this equation over here. That's 4 marks. And 1 mark for getting this equation, the first one, and 1 mark for figuring out that we need to integrate, right? So those are our 6 marks. Alright, so that's the end of the video, and we have done this in under the time given. So if we can do this whilst I'm explaining it, that means that you can too as well. I'll see you guys in the next video, and please like, share, and subscribe, and see you.